If the secret recipe of the world's most famous cola leaked tomorrow, would your drink actually taste any different?
You know the logo. You know the sound.
But almost nobody ever sees what really happens between the secret syrup and the bottle in your hand.
If you stay until around minute 24, you'll see an entire truckload of bottles rejected, for a reason you would never guess just by tasting the drink.
We are not here to spill the formula, but to follow everything that happens after it is mixed.
So take another drink and let's step inside the cola factory together.
Behind every glass of cola, there is a field like this, full of cane or sugar beets that quietly grow sweetness for months.
A mechanical harvester cuts and strips the stalks far faster than any crew with knives ever could. Stalks are sliced into short pieces, ready to be crushed for sugar before they ever see a soda plant. Every load in that trailer is mostly sucrose and fiber, raw fuel for the sugar refinery down the road. From here, loads move quickly. If cane sits in the heat too long, it starts fermenting instead of becoming clean sugar.
Before anything go near a cola factory, raw sweetness is turned into refined sugar or liquid sweetener here.
Inside, impure juice is boiled, crystallized, and washed until almost every crystal looks the same.
These purified crystals will become dry sugar or be melted again into liquid sweeteners.
Some plants ship crystals, others ship syrup blends. Each cola recipe chooses its own balance of cane, beet, or corn-based sweetness.
By the time these tankers leave, the sweetness is precise, repeatable, and ready to be counted in grams per liter instead of a spoonful or two.
From here, liquid sweetener heads to the cola plant, but it is still only one part of the formula.
The biggest ingredient in your drink is not sugar at all. It is water.
Before it ever meets syrup, that water is stripped of sand, rust, and anything that could cloud a bottle. Carbon beds pull out odors and trace chemicals, while finer stages grab whatever particles are left.
Reverse osmosis membranes strip out minerals until this water is cleaner than what most cities put in their pipes.
Ultraviolet light and a touch of disinfectant make sure no stray microbes survive the trip. Ultraviolet light and a touch of disinfectant make sure no stray microbes survive the trip. From here, this water is treated as an ingredient, measured, tested, and logged like anything else in the recipe. If anything drifts outside its limits, this water never makes it to the syrup room.
The so-called secret part of a cola plant lives in rooms like this, small, quiet, and heavily controlled. Entry is logged, cameras watch every move, and only a few people ever swipe into this area.
For decades, people have traded stories about a secret formula locked in a vault. In reality, the recipe is broken into coded parts, and the ingredients arrive as numbered drums like these. Every code is checked and rechecked, so no single person sees the full list of what goes into the concentrate.
What looks like syrup here is so strong that only a few kilograms will flavor an entire tank of soft drink.
One person weighs, another checks the numbers, and a third approves the batch in the control system.
What looks like syrup here is so strong that only a few kilograms will flavor an entire tank of soft drink.
No one here is mixing finished cola from scratch. They are handling a concentrated flavor that was blended somewhere else under equally tight rules.
Different teams handle different tanks, so almost no one sees every component in the same shift.
The legends talk about one person who knows the full recipe, but what really keeps the taste consistent are layers of automation and cross-checks like these.
The actual ratios live as encrypted numbers in control software, not as a handwritten card in someone's wallet.
Even supervisors see only what their role allows. Recipe lines are broken into fragments of data and job steps.
The concentrate becomes uniform enough that any plant on Earth can dilute it and get the same taste. Lab samples are pulled from every batch and stored, just in case someone needs to investigate a problem months later.
If a truckload of soda ever tastes wrong, investigators can trace it back to the exact concentrate batch in minutes.
Each drum carries only a code, not the recipe, and still needs to be diluted precisely at its final destination.
From a distance, these pallets look ordinary, but the codes on their labels are what keep cola tasting the same in dozens of countries.
Once the paperwork clears, this concentrate will travel by truck or shipped to bottlers who never see the original recipe.
What leaves this room is not your soda yet, just the concentrated flavor that will guide every tank in the plant.
In the next step, that intense liquid will meet sugar and ultra-clean water to become the cola base you actually recognize.
This is where ultra-clean water meets sugar to create the thick base syrup for every batch of cola.
Dry sugar drops in measured doses, not by scoops. Every kilogram is tracked.
The goal is simple on paper. Dissolve enough sugar to reach a target sweetness level, and nothing more.
Gentle heat speeds up dissolving, but the plant must avoid cooking the sugar and darkening the syrup.
Once the crystals are fully gone, the sweet liquid is treated like any other ingredient, filtered, cooled, and checked.
Multiple filters catch any stray crystals or particles before the syrup touches flavor concentrate. By this point, it is just sugar and water, no flavor yet, but already held to strict clarity standards.
Cooling the syrup makes it easier to control its density and mix it later without damaging delicate flavor notes.
Here, base syrup and the intense concentrate meet in one controlled, mix-proof environment.
The concentrate line adds flavor in tiny fractions, but the sweetness comes mostly from this sugar syrup. Everything is closed and vented, so aroma does not escape into the room, and contaminants do not fall into your drink.
Because once the syrup's mixed, machines, not taste testers, watch whether it is within spec.
Brix meters read how much dissolved sugar is in the mix, measured down to fractions of a percent. Another sensor checks acidity, which also affects how sweet or sharp the final drink will feel on your tongue.
Temperature matters too. Colder syrup holds carbonation better once CO2 is added.
Ratios of syrup to treated water are defined down to tiny differences, too sweet or too weak, and the batch does not move forward.
Only when every number matches the recipe does this syrup qualify as the mother liquid that will be diluted into cola.
Later, this syrup will be metered into cold water at an exact ratio, too strong or too weak, and thousands of bottles would taste wrong.
Once this base liquid is approved, it leaves the syrup room and heads for its next partner, carbon dioxide. Once this base liquid is approved, it leaves the syrup room and heads for its next partner, carbon dioxide.
This compact unit will turn sweet syrup and ultra-clean water into the fizzy drink you recognize.
First, syrup and chilled water are blended at a precise ratio under controlled pressure.
If the ratio is even a little off here, every bottle downstream would taste too sweet or too bland.
Before any gas is added, the liquid is chilled, because cold cola hangs on to bubbles far better than warm.
Temperature, density, and pressure all line up here so the next ingredient, CO2, can dissolve properly.
That fizz comes from food-grade carbon dioxide stored outside in tanks like this one.
Pressure is stepped down carefully. Too high, and equipment risks damage. Too low, and the drink will not keep its sparkle. Inside, control panels feed just enough gas toward the carbonation system, based on how fast the plant is filling bottles. Every branch is monitored, so gas only flows when the mixer calls for it.
Now the cold liquid and the pressurized gas meet inside a carbonator column, designed to mix them intimately. The goal is not big foam, but millions of tiny bubbles forced into the liquid under pressure. Inside, both pressure and gas dose are held within tight limits, so each liter gets the same bite on your tongue.
The drink is kept very cold here, because gas stays dissolved far better in chilled liquid than in warm.
Once it leaves this point, the COC is trapped in the drink, unless something later lets pressure or temperature drift.
Meters confirm how much gas is actually in the drink, not just what the settings were supposed to be. From here on, every bend and valve is designed to move the drink gently, without shaking the bubbles loose. Surge chambers bleed off tiny pressure spikes, so foam does not build up before filling. Flow is split into multiple lines, so bottle fillers can run fast without creating turbulence. Within seconds, this fizzy stream will be sitting quietly inside tens of thousands of bottles.
The key is to arrive here under calm conditions. Enough gas dissolved, but not enough disturbance to create foam before capping. If pressure or temperature were wrong here, you would see foam boiling in this tube, or worse, caps popping later on the shelf. Because carbonation is already dialed in upstream, these fillers can focus on one job, giving every bottle the exact same volume. From this clear line, the carbonated cola leaves the mixing stage behind and becomes ready for bottling product. Each plastic preform passes through carefully controlled heat, so it softens just enough to be stretched, but not enough to deform the neck.
High-pressure air will stretch those softened tubes against a cold mold, locking in the exact bottle shape.
Seconds ago, these were thumb-sized preforms. Now they are full-sized bottles headed straight toward cleaning and filling.
For glass and cans, fresh containers arrive by the pallet. Clean, but still not clean enough for a drink that will barely be heated. Even brand new bottles get a full cleaning cycle before they are trusted with finished product. Any dust or particles from shipping have to be removed before these cans see a drop of cola.
Here, containers go from new and dusty to as close to sterile as this line can make them. Multiple stages of hot water and detergent knock off glass dust, cardboard fibers, and anything else that should not be in your drink. Sanitizing solution reaches every corner inside the container and then drains away completely.
Filtered air strips away moisture, so microbes have as little help as possible if they land later. By the time they leave here, the inside of every can has seen more treatment than most kitchen glasses at home.
Because the cola itself will not be cooked after filling, this is the last big chance to control contamination.
Every container that reaches this point is treated as almost sterile, ready for cold, carbonated cola with almost no extra heat step to protect it.
Each bottle seals against its own filling head, so pressure and liquid level can be controlled within a few millimeters.
A quick blanket of CO2 is added first to push out air and reduced foaming once the cola arrives.
Flow rate and pressure are tuned so the bottle reaches its exact fill height without a foamy head.
As soon as the level probe sees the right height, the head shuts off and recovers the small extra volume.
From here, they leave the filler still under gentle back pressure, so the gas stays dissolved until the cap is on.
Caps are sorted and fed at a speed that matches the filler. If this stops, the whole line stops.
Each capping head applies a specific torque. Too loose, caps leak. Too tight, threads crack.
That brief rise of foam under the cap is normal, and it happens as pressure inside the bottle equalizes.
If the line is tuned right, the drink stays quiet under the cap, even while thousands of bottles rush past every minute.
Too little pressure or the wrong temperature here, and all that gas would escape as foam instead of staying inside for the customer.
Lines like this can handle tens of thousands of bottles every hour, with only a handful of operators watching screens instead of turning valves by hand. Every tiny adjustment in speed or pressure is tracked, and when the numbers drift, the system knows before your taste buds ever could.
From here, they are no longer just containers. They are finished, sealed drinks on their way to labels and quality checks.
Once the caps are on, every single bottle still has to pass a gauntlet of cameras and sensors. Algorithms look for the correct fill level, cap position, and label placement in a fraction of a second.
If a bottle falls even a little outside the target window, it is automatically kicked off the main line.
Operators review the rejects to see whether they are isolated glitches or early signs of a bigger problem.
Right after vision checks, another machine silently weighs each bottle on the move. Too heavy means too much liquid or trapped gas. Too light means underfilled, or sometimes a tiny leak. Away from the main line, a few bottles are pushed far past normal to see what happens when things go wrong.
These destructive tests confirm the bottles can hold the pressure margin they were designed for.
Even with all the machines, humans still taste and measure every batch. Brix checks confirm the sweetness still matches the target recipe.
Acidity and carbonation are recorded for every lot, building a long history of how the drink behaves.
Even with all the machines, humans still taste and measure every batch.
Once a batch passes basic tests, it moves on as full pallets ready for shipping.
But if any late test shows a concern, a whole pallet can be frozen in place before it leaves the building. One off-spec bottle in a sample can force every case in that lot to be opened back up.
For big brands, consistency is the real secret. Better to sacrifice a whole pallet than risk one faulty bottle carrying their name out the door.
A roll of plain printed film becomes thousands of perfectly aligned labels in just a few minutes.
From here, the system treats every bottle as identical data, tracked by time, by batch, and by line.
A high-speed inkjet adds the date and lot code that link every bottle back to the exact minute it was filled.
Next, bottles are bundled into convenient packs before they ever see a cardboard box. Heat shrinks the film just tight enough to hold the pack, without squeezing the bottles out of shape. Automation folds, fills, and seals cases far faster than any manual line could. Each case carries its own barcode and lot code, linking it back to specific ingredients, lines, and shift times.
Finally, robots take over the heavy lifting, stacking cases into stable, shippable towers.
Layer by layer, software decides the best pattern to keep the load stable and space efficient. Stretch wrap locks the cases together, protecting labels and codes from scuffs on the road. Scanned barcodes tie each pallet to a route, a warehouse, and even a particular truck door. If a problem ever shows up in a store, those codes make it possible to trace the drink back to a specific shift and tank. From here, pallets fan out to thousands of stores, but their digital fingerprints stay behind in the factory's memory.
After packaging, the drinks spend part of their life on these shelves, waiting for trucks instead of customers.
Warehouse software tells every driver exactly which pallet to pull and when.
Each scan updates the inventory system in real time, so planners know exactly what is still in the building.
Trailers are loaded like 3D puzzles to maximize every cubic inch of space. Factories are placed close to big markets, so most trips stay short, saving fuel and time. From regional warehouses, drinks fan out in refrigerated or ambient trucks, depending on climate and recipe.
For overseas markets, pallets become containers, and containers become tiny pieces of a global supply chain.
Temperature and time are tracked from plant to port, so shelf life in the store is still predictable.
Big distributors blend shipments from many factories before sending them to individual stores.
Rotations and expiry dates keep newer pallets behind older ones, so the oldest bottles sell first.
Those tiny codes tie this bottle back to the exact factory, shift, and line where it started.
Every bottle and cup like this started in a factory that tracks millions of tiny details you never see. There is an entire global system quietly working in the background to make it taste exactly the same.
Now that you have seen inside a cola plant, which drink should we follow to its factory next?
Energy drinks, bottled tea, sparkling mineral water. Which factory would you break into first?
Tell us your choice in the comments, subscribe, and turn on notifications to follow the From Farm to Factories drink series.